So very good morning to you all, and my greetings to all the participants on the occasion of Earth Day 2021. The theme of the Earth Day 2021 is Restore Our Earth. As you know, climate change and rapid development are unstoppable. But there are ways like natural process, emerging green technology, and innovative thinking that can restore the world's ecosystem. Today, we are fortunate to have eminent scientist Dr. Atul Kumar Sahai, who is kindly agreed to deliver a talk on role of MoES in enhancing water security over India on this Mother Earth Day. Dr. Atul Kumar Sahai is a scientist G at IITM, Indian Institute of Tropical Meteorology, Ministry of Earth Sciences. He led to the development of operationalization of dynamic ensemble system for predicting heat wave, cold wave, and onset, active and break cycles of Indian summer monsoon, and also tropical cyclones, etc., well in advance of 2 to 3 weeks. As the head climate research and services, India Meteorological Department, Pune, he has implemented global framework for climate services and established a regional center. He also served as a coordinator, Indo-UK Water Center, a virtual center under the Indo-UK collaboration through Ministry of Earth Sciences. Dr. Sahai has been conferred with various awards, including IITM Silver Jubilee Award in 2003 and 2008, IITM Golden Jubilee Award in 2017, and Certificate of Merit Award by Ministry of Earth Sciences in 2008, and various visiting fellowships. He is currently Vice President of India Meteorological Society since 2018, and also core member of WMO expert team on operational prediction from sub-seasonal to long time scale. He also member of various advisory committees of national, international reputed organizations. With this, I warmly invite Dr. Atul Kumar Sahai to deliver his talk. Welcome, sir.
Yeah, good afternoon and thank you, Raju, for giving me the opportunity. So this will be the topic of my talk, role of enhancing water security over India. And let me, yeah. So you see, this is a right side corner. You will see that per capita storage in cubic meter. Russia is almost 30 times to Indian capacity. Brazil is 15 times. US is almost 10 times. China is also, you can say, 5 times. So we are here very, very less, 225 cubic meter per capita storage is there. And so this is one thing is guaranteed accessibility of consumable water is vital for human development. And India is home to, this is very important, that home to 80% of the worldwide human population. And 15% of the worldwide animal population also, not only human, but animal also. However, it has just 2% of land mass and 4% of worldwide freshwater resource assets. So my outline of my talk will be on water security and crisis. And then the role of MoES will be on what are the observed climate changes, because Ministry of Earth Sciences through India Meteorological Department is observing various parameters, precipitation, temperature, and other things since more than 150 years. So what are the changes, observed changes? And then what is the MoES initiative for improving the water security and in India. So water drives economic growth and supports healthy ecosystem, and it is also essential and fundamental for every life. Therefore, water security is not only a water sector issue. It is a broad social, economic, environmental, and political concern. So therefore, encouraging and educating all sectors to consider water in their policies and strategies is essential to sustainability and manage the nexus of water, food, energy, and climate variability, and to support sustainable socio-economic growth and political stability all across the globe. Now, why there is a scarcity? Because you will see that increasing demand, and this demand is increasing due to population growth, industrialization, rapid urbanization, increasing needs of irrigation, increasing domestic use, etc. And over exploitation of groundwater and surface water due to this increasing demand. And then the water pollution, release of industrial and domestic waste into rivers, lakes, and estuaries. This has polluted freshwater sources at an alarming rate in India. So delay in monsoon and climate changing pattern of monsoon intensity and duration and frequency and all those things. And then shift in cash crops. So this is very important. Water is being diverted from food crops to cash crops, and that consume an enormous quantity of water compared to food crops. And top of that is deforestation and mismanagement of wetlands. So therefore, water security, India is suffering from its worst water crisis in the history. And you will see that actually the Indus Valley civilization, this has disappeared suddenly, and many historians and archaeologists believe that this may be due to a catastrophic water scarcity caused either by shifting rivers or by drastic climate change that forced people to abandon city settlements. It seems for India, again, the history is repeating itself. And the latest report in 2018 by Niti Aayog, it has stated that 600 million people, nearly half of our population, they face extreme water stress. And that 3/4 of India's rural households do not have piped potable water and rely on sources that pose a serious health risk. That India has become the world's largest extractor of groundwater, and that 70% of our resources are contaminated, and our major rivers are drying because of pollution. So if you see the status of groundwater, in 1980s, the shallow tube wells were in lakhs, and dug wells were almost 50 lakhs, but that has doubled in 2000. And this has become from 1 lakh to almost 90 lakhs. So tube wells. And this is resulting in, you see, this is just one picture Central Groundwater Board figure. This is depth of water below ground level and in meters. So January 2019, this you see this region, Punjab, Rajasthan, and this region. And after a good monsoon in 2019 also, some regions have improved, but this is still below, you can say 40 meter or something like that. And if you see here, this is the groundwater withdrawals as a percentage of recharge. So more than 100% withdrawal is there, means the recharge is less and withdrawal is more in these regions. So India is on the threshold of a very serious groundwater crisis, which needs mitigation both in the fields and in the policy corridors of the country. Now, if you see the water availability, so in 1951, it was almost around 5,000 cubic meter per capita per year. And in 2001, it is almost at the level of water stress line. And after that, it has gone down, and it is expected that by 2050, this will be below 1,000, and that will be water scarcity line. And if you see the demand, this is in 2000 and expected in 2025 and in 2050. So demand is increasing, and availability due to that or other regions also, availability is decreasing. And if you see the sector-wise share of water, so in 2000 and 2025 and 2050, so agriculture means irrigation is supposed to be, due to various techniques which we are now trying to apply. So this agriculture share, irrigation share may decrease, but industry and energy, this will be increasing manifold. And if you see the rivers, so the water carrying capacity and what we are using or what actually it is utilized. So total potential of is nearly 1900 billion cubic meter, but only 1/3 can be utilized. Brahmaputra all is going in vain in the sea. So mostly we are having, or that this also 50% of Ganga water can be utilized. And if you see the stress, so this is your UP, Punjab, MP. This is the share of irrigation in percentage, and this is total annual water use in billion cubic meter. So irrigation is almost having 80 to 90%, 95%. In Punjab, it is the highest. And if you see this baseline water stress, so this is baseline water stress is that measures the ratio of total water withdrawals and related to annual available renewable surface water supply. So it is actually, it measures chronicle stress rather than drought stress. So these are the regions we are chronically stressed regions, and these regions. So, and why this is happening is, if you see food requirement, so in 50s, it was, since the population was only 400 million, it was around 51 million tons, but it is expected, population is expected to increase by 2050, 1600 million, and this food requirement will be 450 million tons. So therefore, there has to be withdrawal of water. Now, if you see, we have to change our mindset. And we have to change our mindset from, we can tame the river or nature to harvesting every drop. Boon boon se sagar bharta hai. Actually, we have to apply this philosophy. And so the water situation in India is terrifying, that we have seen. But this is also fact that water is world's most replenishable resource. There is enough for everyone. If there is a looming water scarcity, it is because we are mismanaging a precious and life-saving resource. And we are not applying our traditional and ancient science. So this our science, we 1 hectare of land could give 1 million liters of water even in deserts, with extremely clever water harvesting structure with an artificial catchment. So artificial catchment like this is these are the figures of some kundi in Rajasthan, and even without any catchment, water can flow and come, and it will be kept covered so that it will not be means it can be used for drinking and other purposes. So this was our ancient traditional science. And you see the city of Jaisalmer, which had the driest conditions of the world, had flourished despite receiving just 50 mm of rain in a year. And this is thanks to our catching every drop of rain and community management. This is most important, community management. So this maybe apart from government, we have to be responsible for managing the water. And Rajasthan had Kundi system. Ladakh had jinx since more than 200, 300 years. Ladakh had jinx, and Himalayan, basically Himachal Pradesh region had guls and guls. And Bihar had its ahar and pine. Meghalaya had bamboo drip irrigation. Kerala had water harvesting structures actually built into the ghats, and Tamil Nadu has cascaded tanks. So every region of our country valued its rain endowment, and this science was a gentle way of coexisting with nature and not to conquer nature. So we have to revive our traditional science apart from other things. So then what to do? We have to do rainwater harvesting, discouraging wasteful activities, crop diversification to reduce water usage in agriculture, micro irrigation such as drip irrigation, sprinkle irrigation, conservation techniques like zero tillage, raised bed planting and precision farming, organic and nature-based farming, use of wastewater. Actually, more than 50% of wastewater can be reused. And then aquifer recharge and rainwater conservation. And this is through community ponds and recharge wells. So government has taken some initiatives. So in 2017, the government passed groundwater bill. The old bill was replaced in 2017. And this proposes a different regulatory framework from the century-old, outdated, inequitable, and environmentally unfriendly legal regime in place. So it is based now, the new rule is based on the recognition of the unitary nature of water, the need of decentralized control over groundwater, and the necessity to protect it at aquifer level. And then there is another initiative. We are taking global partnership on water management. And you see the Israel Prime Minister here and our Prime Minister, and the formation of a partnership with Israel, the world leader in water governance and conservation, to leverage Israeli experience and knowledge for water conservation in India. Also, government is Clean Ganga project. It checks pollution over Ganga, and This happened after the Central Pollution Control Board has identified almost 1,000 polluting industries, and the Union Water Resources Ministry under the Namami Ganga program has just started a special drive to inspect them to find out if they are complying with the norms of treating industrial effluent before releasing to the river or not. So this is another program by government. And that very important program is a smart residential water management system. So water treatment from water treatment plant and then integrated to the system of the household level. So Indian government has launched a smart water management system, and then data collected through the smart system is used to know exact usage, and also for the development of city planning and other things, the forecast of future usage. So this will play a critical role in the development of a smart cities. And not only government, several NGOs and people, communities and private sector, they have also started. Pani Foundation is people's movement to fight drought, then Rally for Waters, then CSC has started a school for water and waste management, and WTR, that organization is there in Pune, and it has facilitated construction of check dams and many other water harvesting structures to enable better drinking water and sanitation, various villages across the country. And there are various organizations, Jharkhand, PET-C and other things, other organizations, they are also involved and government is supporting them. So many NGOs are also coming into this. So now, the one thing is important, that the precipitation plays an important role in improving the water management. And storage simulation, estimation, runoff, flood and precipitation, stream flow, etc. can be done by hydrological models. So how much precipitation we get and how the pattern is changing. Here comes the role of MoES. And one of the mandate of Ministry of Earth Science is to produce and deliver science-based weather and climate information about future climate change and impacts and climate and weather forecast also, to improve decision making in climate weather sensitive sectors. So now if you see how the climate is changing, so this is the seasonal variability of rainfall. So in the monsoon season, all India, we are getting the highest, almost 85% or 80% of rainfall. And if there is any deficiency in this, we will be having drought-like situation. And also if it is excess, we will be having flood-like situation. And this is your interannual variability of rainfall from 1901 to 1916 and maybe further also. So definitely we don't get any definite trend if you are getting 120 years of data. But there is, and this is another thing, seasonality index. So whatever rain we are getting, so this is more than 0.8, and if this is there, then there is a 3 to 4 months, most of the rain we are getting. These are the regions where we are getting almost throughout the year, except a few 1 or 2 months. But these regions are very much seasonal with 3 months or maybe 2 months also about this Gujarat region. So this is the spatial and temporal variability of rainfall. And then you see there is a almost 30 to 40 years of cycle. So there is no trend in 120 years of data. but there is 30 to 40 years of cycle, which when there may be less rain and there may be more rain. But if you see over central India, so low and moderate events are decreasing, but heavy events more than 10 centimeter and more than 15 centimeter, they are increasing. And if you see district-wise trend also, so except in few regions, it is almost negative trend, and that trend is also significant. But also temperature, if you see, it is last 30 years or so, it is increasing every year very rapidly. So these are the actually climate changes. And then thus the climate is changing, forecasting and how much, which intensity, and how many days or hours. So this is very important for precipitation, and how it is changing the patterns and will change in the future. So already changing, we have discussed, but how it will change in the future. And then the forecasting and changing patterns of consecutive droughts, floods, heavy rainfall, heat waves, cyclones, etc. So these are very important to deal with climate change. And improved monsoon prediction is a way to improve annual water budget management. So this is actually known to us, that improved water management is the key. Now, what is the MoES vision to 2030 priorities to enhance water security? So one is, the first one is climate change implications towards water security, and then see the impacts on declining water quality and quantity. So we have to study this. Then we have to monitor 3D variability of regional hydrological cycle and assess its expected changes and impacts in the future. Then develop an advanced regional climate services framework to cater to the needs of agriculture, water resources, and then alternative energy resources and health also. And then develop district level weather and climate services centers for better coordination with stakeholders for disaster management, especially for droughts and floods. And finally, advanced weather prediction system for block level forecast. We have already started this thing. Is skillful for next 3 to 5 days, and develop sector specific advisories for agriculture, disaster management, water resources, and etc. And also to give quantitative precipitation forecast for flood warnings. And all these things will be used for hydrological information system and flood water. So this was the vision. So to achieve this vision, MoES has launched a monsoon mission program in 2012. Now the second phase is going to end. So then there we are doing short range forecast, working on that, developing models, and now supported to India Meteorological Department for this, extended range prediction, seasonal forecast, and there is a climate change center also. So all these activities, model development activities, are mainly and climate change center are done at Indian Institute of Tropical Meteorology, and then the developed model is handed over to India Meteorological Department for operational use, and further developments are going on. So how we do this actually? So first is, there is a climate trend and change, so that I have shown climate change center. This will be useful for long-term planning. Then we give seasonal forecast, like this year we have given how all India and region-wise rainfall will be there. So this will be give ready signal to stakeholders. Then sub-seasonal extended rain forecast. This is very important to set your operations. And finally, short range 3 to 5 days forecast. This will be given you to go and do the work ahead. So this actually what we do enable better management of the risks of climate variability and change and adaptation to climate change by developing models for finding current and future trends in rainfall, temperature, etc. Season ahead forecast, 2 to 3 weeks ahead forecast, and 1 to 5 days ahead forecast. And this will provide access to relevant climate information to stakeholders, which can empower them to anticipate and confront climate-related risks and opportunities. Now, we have to, these things are achieved by models. And first is the numerical weather prediction model. So the idea of numerical weather prediction is to sample the state of the fluid at given time. So that is called initial condition. And then use the equations of motion to estimate the state of the fluid in future time. So these are the equations of motion and physics, conservation of mass, first law of thermodynamics, Newton's second law, and there are various other conservation of water vapor, chemical species, etc. These equations are very complex differential equations, and this can be solved by numerically on grid. Then comes on what resolution and how many physical processes will be incorporated into this. If not, then how they can be parameterized. Then how to initialize and how many ensembles. These are very 4 dimensions: resolution, physical process, initialization, and ensembles, where we have to be precise, and also we have to see what is our computational power, and based on that we have to decide. So this is some of these are some of your processes. So you can see there is deep convection, shallow convection, then clouds are reflecting short wave, and also they are emitting long wave. So, and sensible heat flux, lattice, turbulent mixing, all these things are there, non-orographic, and this, then chemistry is there, ozone and methane and other things. So these are not explicitly resolved in the model, but they have to be parameterized through the resolved scales in terms of mass, momentum, and heat transfers. So this is being done. Now, you see what I told you, the 4 dimensions. So these are the dimensions. So one is the duration, how many days or hours we want to run the model, and how many ensemble size, and then which capacity, complexity, how many process we are parameterizing. Then what will be the resolution? So it will be 10 kilometer by 10 kilometer, 100 kilometer by 100 kilometer, or what may be. And how much data we can assimilate for the initial conditions. So this is actually all these things drives the need of HPC, high performance computing system. And if you see as a computational problem, this global weather numerical prediction is comparable to the simulation of the human brain and of the evolution of early universe. So very big, but it has to be performed every day. at major centers. So this is what the unique thing is every day, and many places every 6 hours, and depending on the situation every hour also. But the computational need is huge. And here is one figure. If you are going model resolution from 10 kilometer to 5 kilometer, you see how the computational number of compute nodes are increasing. It is a exponential increase. And also the power consumption is increasing exponentially. So this megawatt ampere, megavolt ampere. So this is actually, if you see from up to 5, it is like this. Then when you are going 5 to 3 or 2, so enormous power is required. So electricity is not available everywhere of this capacity to run the system globally for so many days and these things. Therefore, we have to compromise on which resolution and what we are going to do. And if you see the so Ministry of Earth Science has launched, and the other is high performance computing system. So it has acquired, and now it is at 2 places. Pratyush is in IITM and Mihir is in NCMRWF, at NCMRWF, and the peak performance of here, which is at IITM, is 4.5. It is actually almost 7 this thing. If you add both computing system for operations and research, and then this we are going to make it 10 times very soon. So these are very important to know that huge computational requirement is there. And these are some CMIP 5 results which show that a strong monsoon in the future, a strong monsoon means flood type of situation. So that is going to increase, and weak monsoon is also going to increase. So more floods and more droughts will be there in the future. And then not only that, there will be more active in the strong monsoon, and more long breaks in the weak monsoon. So this is also going to happen. It is projected like that. Also for active break situation, it is seen that precipitation anomalies would become more intense. If you see, this is the difference. So this is what the historical current situation. So this is active and this is break. So the active and break both are becoming intense and also regionally extended. And in CMIP 6 also the situation is not changing much, and you see the variability is mean is increasing and variability is very much increasing. So from here to here in the far, this is the 50s and this is in the end of century. So it is going to increase, the variability is going to increase very much. So then, but there is a lot of uncertainties in the future projection among model to model. But one thing is that despite all these uncertainties and in the representation of climate process in the model, the climate model in the current generation represents the hydrological cycle to the extent that the mean monsoon and its variability also is predictable up to a certain extent. And then, so in the backdrop of projected climate change scenarios, rainfall prediction is going to be complex, but it is very important. So as I have told you that monsoon mission has been launched for this only. And this is one of the system which we have developed for the extended range 2 to 4 weeks prediction system. And the model was initially taken from NCEP USA under monsoon mission. And now the initial conditions are generated by NCMRWF for atmosphere and ocean in COIS, Hyderabad. And then these initial conditions are perturbed, and this model is run at 2 resolution. And finally, we are getting a multimodal ensemble, and we are able to predict active break, monsoon intraseasonal oscillation, MJO, heat wave, cold wave, northeast monsoon, cyclogenesis, and it has applications in various sectors: agriculture, hydrology, energy, health sector, and urban planning. And if we have compared the skill of our model with the world's best model, Equipment Office and ECMWF, and they are almost comparable in the most of the cases. So now it is operational at IMD, and real-time forecasts are given for 2 to 3 weeks lead time of rainfall, temperature, humidity, large-scale indices of interseasonal oscillation, SPI, etc. And they are being application is there in onset of monsoon, progression, withdrawal of monsoon, formation of low pressure system, propagation of convective phases, mid-latitude intrusions, and then in agriculture for drought monitoring, revival of active break spells, persistence of break spells, continuous rain, inputs to crop model and hydrological model, and then health and flood outlook and reservoir management also. So I will show you some example. This is the onset on 2014. So we told that a low pressure system might form over Bay of Bengal around 25th May. So this was from the 16th May initial condition and move northwards. But onset will be there, but strengthening will not be there because this will disappear. And after 15th June only, another system will be coming, and then that will take the monsoon forward. So that actually happened, that though onset was around 4th June, but the progression was very much delayed after that, and means around 20th June itself, again it has a second wave started from Bay of Bengal, and that has moved to this. Then delayed progression also in 2014 we have predicted with the 5th June, and withdrawal in 2013 also from the 8th September initial condition. We actually, in observation, there was no rain in Rajasthan and this region, western part of the country, from 8th September itself. And we were going to say that monsoon withdrawal already started, has been declared. But then we found that in our model is showing that one system will be formed around 20th of September, and that will move up to Rajasthan. And then we stopped giving monsoon withdrawal, and actually it happened, and the system went up to Rajasthan. So these are the things for onset, withdrawal, and propagation. And also monthly extremes can be well predicted. So this is one example in 2013. You see this this line is your observation, and these bars are forecast. So up to 4 weeks in advance, it was able to forecast in the month of June, which was very high rainfall. But 4 months, 20 days in advance also we can predict this. So this is our monthly region. And even if you see the 2014, it was almost the whole June was dry, and that was well predicted up to 4th week. So this type of prediction was not available prior to monsoon mission launch. Now it is possible. And then even extreme events, this is your Uttarakhand rainfall event. And this is the observation, and these are the forecast. You can see the models are giving up to some extent the formation and movement of the low system and rainfall also. And this is one example of a Soba cyclone, which formed around 7th of June. But from 31st of May itself, we told that one system will be formed and it will move up to Oman coast. So this is what from here you see it is moving first, second, third, fourth, fifth. Now you see 6th, 7th. So from 31st May itself, this was predicted. But if you see compared to this was the on same 7th June prediction by JTWC joint track prediction system, and this is not showing going towards Oman. It is going like this, and our each model members were going like this. Some members were also going in this direction. But if you see the probability of highest probability line, so this is up to 10%. So all are showing in this direction. So this is what we are getting. And this is the same example for but two seasons, 2016, from 11th May itself, we have predicted that system will be formed and going there, though there it was slightly means not going with exactly that, slightly delayed, but in these things are predictable. So, and if you see the active break cycle, this is one example in 2017, and this was the active condition in by the end of from middle of July to end of July. And then there was, this is the observation, and then there was a big break from the end of July to almost 20th of August. And then there was again some good rainfall activity. And then again there was a break type of situation. So I have given here A, B, C, D. So A is when it is going to, so if there is a active condition, so people want to know, a stakeholder wants to know that how long it will continue and when it is going to be in a break condition. And if there is a break, how long break will continue, when it will go to active condition. So these are very important things for hydrology and agriculture both. So transition from active to break, whether it was predicted or not, and then long spell of break was predicted or not, and then again from break to active was predicted or not, and active to again break was predicted, and if predicted, how much in advance it was predicted. So this is one example of active to weak transition. So we have given 4 to 10th August. So in this period, 4 to 10th August week, and this was predicted from 19th July itself, that it is going to, if you see the all India mean minus 32.5%, and actually observed was minus 25.4. So this up to 3 weeks in advance from 19th July, and 19th July actually you see here it was a very active condition. But then we predicted that in the first week of August, it is going to be a break-like condition. So this was well predicted 3 weeks in advance. Then the second is how long it will be. So from 26th July, it's still it was in active condition. And you see, if you see the observation from 28th to 3rd August, 4th to 10th August, and 11th to 17th August. And this was from 26th July itself, it was predicted that how much it will, how many days it is going to stay there. So almost 3 weeks, it will be break-like of situation. So this is what, and then from active to break to active. This is 25th to 31st August, end of August. This was also predicted from 9th August. And then again from long dry spell in the September. So that was also predicted. So this was not predicted by up to 3 weeks, but up to 2 weeks it was predicted. So sometimes it's 2 weeks, and sometimes it is 3 weeks in advance we can predict active and break. And there is another, we are improving this further by artificial intelligence and machine learning. I'm not going to show these things. So the conclusion is monsoon mission and high performance computing programs of Ministry of Earth Sciences has led to successful monsoon forecasts. And the extended 3 to 4 week ensemble prediction system has reasonable skill in predicting the onset, progression, withdrawal, active break cycle of monsoon, extreme rainfall events, genesis, and track of tropical cyclones, heat wave, cold waves. I am not shown, but it is having good skill. And the skills are at par with the best operational forecast system elsewhere. However, we see that there are spatio-temporal errors in most of the cases. So to rectify this, efforts are underway to reduce these errors and using post-processing techniques of dynamical downscaling and artificial intelligence and machine learning, and also improving the model physics. And in the current climate change scenarios, where extreme events are increasing, monsoon forecast with longer subseasonal lead time would provide better information support system to stakeholders. And therefore, and this will be integrated to hydrological forecast with meteorological forecast and this better management of water resources. So we are working on that in the monsoon mission also, how to give better hydrological forecast of stream flow and other things. And then finally, so rainwater harvesting, this is for general conclusion, harvesting should be a national priority and be done jointly by the government, people, NGOs, local bodies like Gram Panchayat, Jila Panchayats, and there will be, if this is done, there will be no farmers suicide. So this is what I wanted to say, and thank you.
Thank you, sir. Thank you very much for elaborating a lecture on the role of MoES in enhancing the water security over India. So you had covered nicely about the status of water over India, water level status, and also the model predicting system of Indian. These are different various models for accurate prediction of high impact weather events due to meteorological convection, tropical cyclones, and active and break cycles. So thank you very much, and I hope hopefully this MoES can surely come up with more accurate weather prediction for block levels. So I think we have some couple of questions. It is there. So I will go through that one. This is Professor Devara. An excellent talk and informative talk. Many thanks to Dr. Sahai. How MoES has been supporting the water harvesting, curbing of water pollution, water purification with latest techniques such as nanoparticle treatment and water recycling. So
yeah, actually, as I told you, MoES job is only to give hydrological forecast and meteorological forecast and monitoring and climate change, and on this we are working. But now it is not operational, but almost 4 years there was a Indo-UK Water Center activity running with jointly with MoES and NERC of UK. And there we have launched several initiatives for in Sundarban area in Kerala, Memnad lakes and other places, how the pollution is going on, how to treat with technologies which are available in UK and India. So all these things, initiatives we did, but still that is not in the purview of MoES for water harvesting and this water pollution curbing. So that is the thing.
Another question from Professor Devara. How the current models are giving better forecast about the regions of floods and droughts. In these efforts, how the latest artificial intelligence and machine learning techniques can help?
Yes, sir. Actually, we have to see on temporal scales and the scale of the event. So, suppose Mumbai event or Chennai event or something like that. The models, if you see in the probabilistic sense, models are able to give that extreme precipitation is going to happen. So this is one very extreme also is possible. But how much extreme will be the quantity, still that is not only what we are running the models and doing this thing, anywhere in the world, the quantity of rainfall for the extreme events are not possible. But in a statistic sense that it will be very extreme event that can be predicted. Now AI ML is being used and we are working on that, and with the help of various universities in India, MoES has launched one program, and we have invited various projects. Now they will be cleared. So there we want to use the information, observed information with the model product, model output, and to use the machine learning technique to accurately capture the quantity also. So this is still an area where we feel that artificial intelligence can help us in better way. And if you see the models as such, they have to produce 600 millimeter rainfall is slightly difficult in this sense. But artificial intelligence will help us doing that. Thank you.
There is another question, sir. Ms. Archana. Why there is a break number of days are long or more compared to active number of days?
Yeah, this is not breaks are more. Actually, active days are also becoming more. It depends on the mean monsoon condition. If mean monsoon condition is for good monsoon, then in those years you will get long active spells. But if the mean condition is like suppose El Nino year or something like that is such that it will be leading to drought, then in those years breaks will be longer. So it is not that always this is there, but climate change projections are showing that or even the observed which I have shown, the light rains are number of days of light rains are decreasing. So either there will be no rain or there will be very heavy rain. So it is like that. Okay.
There is another question by Akshay. What could be the role of micro rainwater harvesting in potential areas for different locations in India?
This is a very big role. Actually, what I told you that our traditional system was micro level water harvesting and management only, and we have to that is mostly now destroyed, and we thought that we will have electric pumps, water pumps, and we will take more water from ground and do everything. So we have slowly destroyed our traditional micro level management water harvesting systems. That actually I have told that they are very important, and we are not against that there should not be dams and all those things are also required, but simultaneously we have to also see that micro level water harvesting has to we have to more concentrate on that, empower those things, and that has to be managed by people, not by government.
This Dr. Amrit Kumar, his question is any role of COVID-19 relationship with the climate change?
That people are studying still. COVID-19 itself is a every day we are coming with the new theories, so we don't know. But one thing is there that that pollution, since the movement was less, and vehicles, and even many places factories were also not means they were also closed, and so many things. So whatever we were pumping in the atmosphere, that we are not that has been reduced, and definitely there will be some role of climate change, which can be seen after few years only, and that will be studied. Like there will be, if there will be, suppose one any earthquake or something, like things happen, and some debris is there in the atmosphere, so effect is seen after some time. So we will see after some time, and then models we will see. But that aerosol concentrations have been definitely decreased, but other climate effects still we have to study.
There is a question from Dr. Swatantra Kumar Dubey. Is any dimension which is used for the water security and apply in all regions of India?
I cannot comment on that actually.
There are a couple of questions also. Just I will take up important questions. How about desalination techniques practicability in India?
There are some
Because some states are doing desalination.
evidences that it is okay, but I still, that's what I'm saying. I am not expert on those things. Yeah.
So there is a question from Dr. ABM Subbarao. Dryness increasing in northwestern parts of India, besides central irrigation, borewell irrigation is high in these areas. If there is a fail in rainfall recharging of aquifers are failed in these areas, so what kind of measures planned or executed in these areas?
So that also I can't say on that what they have done because but means they have to revive the traditional practice of Rajasthan desert region. So that I don't know how much, because you see some 200, 300 years ago something was built, and that still that is satisfying, and there are many artificial ponds and other things have been also, and that they are old only. But now what Central Water Groundwater Board is doing and all those things, so that I'm not aware of that.
Yeah, there is one last question, sir. What are your suggestions for water management during extreme events? What measures can be taken up at the community level?
Yeah, that also, you see, water management, there are other things like, you see, traditional I am talking again. In Bihar, northeast Bihar, that region is almost always flooded. So there are a lot of ponds and these things, they fill it. and they do the agriculture of makhana. So almost towards 80% of makhana is grown there in those lands. So you have to take the opportunity of whatever natural things are there. But if the extremes means if they are coming once in 100 years, so people will not be prepared for that. But still, suppose if there is a forecast and already the situation, I'm saying about dam management and other things, not for the public perspective. And so there is, for dams, there is a rule of curve and this, that they have to keep this much water and then they will not release up to this date and like that and like that. But now our predictions are improving. So they have to see what is the prediction, and based on that, like in 2011 Mahanadi, the river flood in September, there they have opened all the 12 gates of Hirakund Dam and at a time when there was full of water. So they could have, because there was prediction, and or if it is not there, since now it is there. So this type of thing. So if they are sure that there will be more rain coming into this, so they should start releasing water in advance, means some 2-3 days in advance, and warn the public, and then other things public also can take initiatives to go somewhere and something like that and do these things. So this, in this way, this can be managed. So rule of curve has to be dynamic, and it has to see how is the weather forecast and how it is going to do, and then dam management has to be done like that.
And also the river linking is also will be very helpful for managing.
Yeah, river linking program is there, but still there are a lot of problems also, because sometimes you have to lift something, and then so means water lifting and other things are there. I don't know how much it will be efficient, but that is also one way. Not all the rivers, but some rivers can be linked.
Yeah, I think there is no questions. Okay, so thank you.
And I'm sorry that most of the questions I might have not given good answer, because I'm not expert in water security and wastewater management and this. But if it is weather and this, there I can say anything. Okay, thank you.
Thank you, sir. I take this opportunity to thank Dr. A.K. Sahai for giving these wonderful lectures. And also I thank Professor Amit Jain, our Pro-Vice Chancellor, for encouraging to organize webinar in this Earth Day. So, and also I thank Honorable Chancellor Dr. Asim Chauhan, sir, for his constant support in our Ocean Atmospheric Science and Technology Center. So thank you, Dr. Sahaji, for